to say, happy International Pi Day. Today is the Pi Day, and I'm presenting today on this topic, mathematics for artificial intelligence. So my subtopic is like unlocking the mathematical magic. So we're actually exploring the magic or the mathematics behind those smart machines. So we talk a lot about artificial intelligence. Similarly, intelligent system in machines, our computer systems, and so many other computer systems. And so, what is the reason and the fuel behind that particular system? So mathematics is one of them. So we will actually explore those ideas. So this can be one question for you. Like we are using various chatbots. There are lots of chatbots emerging, and we're using so many different AI related chatbots, generative AI related chatbots like ChatGPT. So have you ever imagined, or have you ever thought like how do these AI chatbots like work? So you can think. And so you can see like so many chatbots we are using these days, like ChatGPT, DeepSeek, Perplexity, maybe Grok and other platforms. But have you ever noticed or imagined like what is the the particular aspect or maybe the engine that help these platforms work? So I have one particular a demo for you. I think this can be helpful for you to understand one particular situation of how mathematics or maybe mathematical ideas can be used in machines. So let me show you one particular demo. I think the screen is visible to you. This here. So there is one project you can see like Google's Teachable Machine. So I have Teachable Machine here. So go to Teachable Machine, and so you can get started. So there are different projects like image project, audio project, or pose related project. This particular platform is useful for you to classify objects. Like if you have two different images of maybe cat and dog, and you can train your model to predict the particular image, whether that particular image is dog or cat. So for the image classification, I use this image project here. So I go here and I choose standard image based project, and you can use webcam or you can upload the images. So I have some images here. So I have to go to upload. I'm here. So I have this project, training data. So I have this project to classify the particular the images, dog or tiger. So I have images of dogs, some images, like I have to upload all these images here. It is uploading. So I just rename it. So the name of class is dog, and another class is I'll have to upload the images of tiger. So training data, tigers, few images here. So this is the class tiger. And since I have I've done uploaded images of two different things, dog and tiger, I have to train this model. So you have to click this train model. It takes few seconds to train that particular model. It is done now. And so I have to choose like webcam here. So first I uploaded two different images like dog and tiger. So I have few images like 26 images of dog and 30 images of tiger, and I have trained this particular model by clicking this training model. And so I'll have to now upload one particular image and ask this particular model to classify whether that particular model is dog or cat. So let me choose the testing data. So I have testing data here. For example, I have this data, like for example this data, and let's see whether the model can classify this. And it now it can actually predict or classify that particular image is of tiger, you can see like this is 100% probability. So out of these two classification, like dog and tiger, the particular model is able to identify the image of the tiger. So let me choose another maybe data like this and see here. So again, this particular model is able to identify the image of this dog. So after these two different training data, it actually predicting or classifying so it is a problem of binary classification. So among dog and tiger, we have two sets of data, and if you upload another data, it can identify that particular image, right? Whether it is a dog or cat or any other animal. For example, you can upload another image and see whether this image model can identify the particular maybe animal or face in the image. So I think you have seen one type of mathematics use here. You see the use of prediction, or we generally use maybe sometimes you know about this logistic regression or regression in a simple linear regression. So this particular the teachable machine related idea, or the platform uses regression model or logistic model to solve the problem of binary classification. And you see the number of mathematical operations in a modern AI systems, whether you talk about robotics, whether you talk about computer vision, or you talk about maybe chatbots or driverless vehicles, you see mathematics there, the use of mathematics there. So it accesses the number of stars in our galaxy. So it is okay to define artificial intelligence. It's intelligent intelligence of machines. Like you have machines and that can mimic human behavior, maybe human intelligence, like it can learn, it can problem solve, or it can identify like a particular picture in a maybe a face or maybe animal in a particular picture. And so math is all about the language of AI that actually uses to process data, launch pattern in the data, and make informed decisions and other different decisions. And analogy here is that building artificial intelligence systems without math is like baking a pie without ingredients. It just don't work. And mathematics turns raw data into actionable insight. Example, maybe, so one of the problem can be detecting spam emails, like somebody is sending email to you, and your system can should be able to identify whether that particular image is spam or not. And so you see the recommendation system in maybe social media like Facebook or maybe Twitter, or YouTube channels which recommend movies based on your interest or the past history. And chatbots actually predicting text like ChatGPT. We'll see other examples in a bit. And so this is the artificial intelligence hierarchy. You can see artificial intelligence, it's a broad field and philosophical foundation of how to make smart machines or intelligent machines that can maybe compete with human being. And machine learning is a subfield of artificial intelligence, which is a platform where we train algorithms like I did before. So algorithms and that has ability to learn from massive amount of data. And deep learning is a very subfield and important field of artificial intelligence, which uses artificial neural networks similar to like human neural network, and to train the data and learn from it, and execute the solution and provide the output. And generative AI, which is a very buzzword in today's artificial intelligence industry, which creates new content by mimicking the pattern in the dataset we provided. So you see the artificial intelligence now. In 2010 and before 2015, there was a narrow artificial intelligence which were developed to perform a very limited task. Maybe Siri is one of the examples, or Google Assistant can be one of the examples, or maybe Google Map is one example of narrow artificial intelligence, which was actually particularly designed to perform a very specific task, right? And we're in the position of broad artificial intelligence. We are not achieving general artificial intelligence. General artificial intelligence is that kind of AI which is able to, you know, perform very human-like tasks or maybe very general tasks. So I don't know whether you know this particular news about Manas AI of China, so which is a very Chinese company and developing this Manas AI. So you can see the news. So Manas AI can be one form, a very basic form of general artificial intelligence, which has ability to perform various tasks using its different agents. But we are in the phase of broad artificial intelligence, which is about using chatbots and various other AI platforms like driverless vehicles or other robots related things in our day-to-day tasks. So, and if you see the machine learning algorithms, since we're talking about how artificial intelligence systems are using mathematics to build their system, you see these are the engine of AI systems today. Like whether you talk about ChatGPT or other platforms, right? So these engines, like you can see various algorithms. I think you are familiar with some of them. Like linear regression is very simple and we use every day, maybe since we are from mathematics background and we sometimes we are familiar with this. Logistic regression is there. Distance tree is very important machine learning algorithms for very classification types of problem. Support vector machine, KNN, it's k nearest neighbor. Dimensional reduction is there, random forest algorithm is there, k-means clustering, naive Bayes. So I think you are familiar with Bayes theorem, and this naive Bayes uses Bayes theorem to further very classification problems. So these are the engines of modern AI systems. So I have one example like linear regression, and our task is to predict the price of a house based on its size, right? So we have size in the x-axis, and we have the list of price in the y-axis, and we have this particular training data, and we formed this particular fitted line plot, like price is equal to b naught, that's a constant, plus b1, that's a slope, and size of the house. And this particular and general model can be used to predict the price of a house based on the given size of that house. So this can be one of the important examples of how prediction can work in artificial intelligence system. For example, you use ChatGPT and you see so I want to give another example. Like when you type another a particular email to your professor, mentioning that so you are not able to join today's class, and you write like you are not, and so that particular system, like email system, predicting that particular word, like so I'm not able, and to like this kind of word it can predict. So that's the actually the output, and that is due to the help of linear regression or the prediction related problems. When you talk about mathematical foundation, we can see the AI pipeline here. First of all, we have to collect the data, because data are the fuel for artificial intelligence system. Like ChatGPT works based on the provided data. So numbers, text, images, maybe sound. So that can be converted into mathematical representation. I'll show you some of the examples later. And we'll use data processing. We have to so there is a massive amount of data, and data are not cleaned. So we have to clean it to utilize in the AI system. So we have to clean it, normalize it, and transform by using various statistical method. And the third step is to develop model or build the model. So we have to create mathematical structure that learn patterns, like we use that linear regression before, and maybe support vector machine or other different algorithms you can see. And we have to train that particular model. Suppose we have linear regression, and we have to train based on the data we have, and we have to test its accuracy, whether it can predict the things we want, right? And the final one is decision making. So this is the pipeline we use generally in AI systems. So for example, you can see one example like real world information to numerical representation. Suppose we are training one maybe large language models like generative pre-trained transformer. First, what we have to do is we have to convert the word into vectors, because your computer doesn't understand text. Your computer doesn't understand your feelings, or whatever your text has, like feelings, emotions, or maybe expressions, but it can understand numbers. So I have to convert that text into numbers, like vectors and matrices.
Netra
And
sir, I think it is 5:30. I think you need to finish within 5 minutes.
okay, so yeah. And so for example, you have image, and image will be translated into pixels, because image is formed or developed based on the pixel values, and sound becomes frequency distribution. So we'll convert these things, real world things, into numbers. So there's some core mathematical areas in AI. I'll show you here, like linear algebra. So if we're talking about artificial intelligence in broad sense, so they use these mathematical things. Like linear algebra is important in the AI system to understand data transformation, and like vector spaces are very, very important. So calculus for optimization problem, and probability and statistics for maybe likelihood design, making predictions. So these are three foundational concepts. Similarly, graph theory is also important. Discrete mathematics is also important in AI model development and deployment. So if you see the essential role of linear algebra in AI systems, vectors, matrices, and transformation are very, very important concept to build those models. If you see like vectors and matrices, that is called the language of the data in AI system. So vectors list of numbers, like we have to convert those numbers into list, and matrices will be used. So one example can be like Netflix recommendation, or maybe YouTube recommendation, who is actually recommend you the movies or any videos based on your history, right? So this is one example to convert particular text data. So you have three different examples, like you created I enjoy flying, I like NLP, I like deep learning. These three examples. Now you have to convert these three examples into vector system, or matrices. And you see, like I have to write all the names here, like I like enjoy deep learning, NLP, flying, these kind of things, and same here. And you see from I to I, the prediction capacity is 0, because you see there is no I after I here. But if you see this like, after I there is two like I enjoy is there, but I like NLP, I like deep learning. So there are two different examples, and the value is 2. And you can see other examples, like from one word to another word, what is the the frequency of word happening in that particular examples, and AI learns based on this particular pattern. And this is the one example of matrices used in AI systems. So user probability and statistics is very important, because we are dealing with uncertainty, and so predicting, like ChatGPT, giving output based on users' input. So that's the idea of predicting things. So, and it's all about probability and statistics. So the role of probability and statistics in artificial intelligence, like inference making kind of things, prediction kind of tasks, maybe understanding uncertainty and enhancing effectiveness, we use probability and statistics. So one example can be logistic regression, and I use this particular model in that binary classification problem, like in teachable machine of Google. So this particular logistic regression predict the binary outcome based on your data provided to the system. And calculus, it is useful for model optimization, because we generally need optimized model which can perform better and provide output, best output by using very limited resources, right? So for that, we need calculus, like derivative, integration, those things that helps artificial intelligence system to optimize their capacity and work best on very limited resources. So some of the examples we can see, like computer vision these days, like your facial recognition camera. If you have your face installed in your mobile phone, it only unlocks your based on your face zone, but not others' face. So it uses like linear algebra, convolutional neural network concept, and optimization related concept to develop various computer vision related tasks. So you see these particular examples. So there is number 2, and this particular number 2 is converted into different matrices. Like you can see different N1 channels here, and similarly N2 channels and other things. And so this particular last thing is different color thing. This is a neural network actually, and this works best on the provided different neurons. The input available here. And for the natural language processing, which is important aspect of artificial intelligence, which works by understanding the human language. It can understand humans input and understand the language, and it can generate, like ChatGPT. When you provide the context, it can read it and provide the output based on that. So LMS such as ChatGPT use vector embeddings, probability, and attention mechanism to capture semantic relationship and predict the context. Similarly, in reinforcement learning, which learns from experience, like you see this example of DeepSeek, which is a very important example of the use of reinforcement learning, which actually learns from the past experiences, or maybe trial and error kind of mechanism. And it uses like Markov decision process, probability, and optimization. So mathematics is used here. So you say one example, and which is a very familiar example, like linear algebra. You can see these things. So like in linear algebra, words become vectors. So we'll convert that word into vectors, like in numbers based on the context it used in that training examples. And uses calculus to, like gradient descent function is very important, aspect of machine learning and AI systems. And similarly, probability and statistics to predict the next word, like autocomplete kind of things. We use this probability and statistics in that system. And algorithms is a very, very important aspect in machine learning or AI systems. So I don't want to go here, but I have one video, like this is a very 1-minute video, so you can watch this video and to see how large language models work.
Large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. Instead of predicting one word with certainty, though, what it does is assign a probability of possible next words. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is a given prompt typically gives a different answer each time it's run.
Yeah.
A large language model.
So, and the conclusion is that behind every AI achievement today is elegant mathematics, and without mathematics, AI system can be built. So thank you for the time and listening to me.